So now we are going to obtain the relation between two branches of physics. So first one is linear mechanism and the other one is rotational mechanism. So first of all, the quantity which I am going to understand over here is the displacement what you have understand in linear motion. Here we will see in the kind of rotational motion, it is known as the angular displacement. So, which particular quantity you are considering as angular displacement? So, in this case, you have to consider a motion of a rigid body, means a rotational motion. So, here we have considered the motion of rigid body. That means a rotational motion, and here the rotational axis is OZ, which is fixed. It is not actually seen in the figure, but if you see this axis, then this axis is OZ, which is the fixed rotational axis, and our object is rotating about this particular axis that is perpendicular to the plane of paper. See, it is also perpendicular to OX and also perpendicular to OY. Here we have considered the particle of t at position this at time t is equals to t, and after time interval delta t, means at time t is equals to t plus delta t, are shown in this figure. But here I am consider the particle p of a rigid body. So at the time t is equals to t, first of all, the particle which I am consider over here is p of the rigid body. Now, at the time in which there is an angle made by joining it to the center of the circular path O with a definite reference line. See, this is the line joining to the center O. Joining to the center O with the angle made to the reference line. See, from the figure there is a reference line. In a given time, t is equals to t is called the angular position. So now you all are aware first of all with the position, and here the angular word comes with the angle of reference line, which is OX. Now Suppose your particle performs circular motion. Then this particle P is now at P dash. The time. So this is the new position of particle. After the circular motion, the time is also changing from t is equals to t plus delta t. Now, the angle with the reference line OX is also changed to theta plus delta theta because there is only change is shown, but this angle we also have to add. So this total angle will be theta plus delta theta. Now see, as the rigid body is performing circular motion, then this dotted line which is shown, it is original, and the curved line is called the actual position after circular motion, which reflects to angle theta plus delta theta. So now with all this property we are considering the change in angular position of the particle. Is called the angular displacement. Which is the actual reason due to the change in the time interval as well as the change in angle. Now suppose any one of these change is not happening. So suppose the time interval is not changing but the value of angle changes. So such kind of possibilities is not occurring in this angular displacement. Now since the relative displacement between the particles of rigid body is equal, then the angular displacement will be equal in the same time interval for all the particles. And this is also equal for all the particles of rigid body. Now, as we have considered this discussion, the rotational motion of the body can be described by the motion of a single particle. So we not have to consider the motion of all the particles. If we have studied the motion about a single particle, then we can consider the same nature of motion for all other particles. Now, the SI unit of angular displacement is radian because the position are changing in terms of the angle. So we have to consider now the SI unit as radian, and so we cannot write down its dimensional formula because we are writing the dimensional formula only in terms of length, mass and time. But if you want to consider this radian as only in terms of length, then the SI unit will be L1. But here the angle is coming or is introducing in the angular displacement, so it is not possible to write down its dimensional formula. So now let's see the another relation between angular speed and angular velocity. Let's start the second relation for angular speed or angular velocity. So, for finding out these two relations, I am consider over here that a rigid body performs a rotational motion and is having some angular displacement, because as it performs the rotational motion, then there will be some displacement. So, according to the definition of angular speed, we have one equation for bracket omega, in which this omega refers for angular speed and is given by the angular displacement. See, now the angular speed and angular velocity both are having the same meanings, because in both the case we are taking the displacement and is divided by the time interval for that. So this is same as the equation in linear motion. Now I am assuming over here that the angular displacement is of the particle of a rigid body is delta theta, and the time interval in which the angle changes from theta to delta theta is delta t. So now I can substitute the values in the equation of omega is equals to delta theta over delta t. So this is the equation of angular speed. But if you want to find out the instantaneous angular speed, then as we are performing the operations, we have to apply the limit of denominator tends to 0. So I have to apply limit delta t tends to 0 in equation 1. So my equation 1 will now become a simple omega, because now bracket will be cancelled out, is equals to limit delta t tends to 0 delta theta over delta t is now reduced to d theta by dt. That is the equation number 2. So equation 1 and 2 both are also known as the angular speed of the rigid body at time t. Now, if you want to find out the unit of it, that means the unit of angular velocity is angular displacement is radian, and the time interval is in second, and that is in the denominator. So I can write down its unit is radian per second, or you can say that is rotation per second. So both are the units of angular speed, or we can say angular velocity. But whenever you are consider the velocity, the direction of displacement is necessary. Means the direction of delta theta is important, and to find out the direction of angular velocity can be determined by the right hand screw rule. So now I am giving you a schematic from which you will find out the direction of angular velocity, and from that you can now return the omega as vector omega, and now the direction of vector omega can be determined by, see, I have considered the motion of a rigid body in circular path in along to this axis. Now if you want to find out your particle is moving along this direction, then according to right hand screw rule, the direction of velocity is along the north direction or in the upper direction, because the screw is rotating in this way. So the screw will come outside of the wall, and hence the direction of velocity is in the upper direction. Similarly, if you consider the reverse motion, means this kind of motion, suppose you are considered, then what happens? Then this screw will go inside the wall, and the direction of velocity will be in the south pole. And now with this, our angular speed and angular velocity is over. Now we will derive the scalar relation between angular velocity and linear velocity.